Welcome back. In this video, we're going to try to simplify this composite function of the sine and the arctangent. Here we have the domain of definition is the set of real numbers. So this is defined for any value of r. You can prove that by using the definition of the composite functions. Note here that we know that the arctangent is always between minus pi over 2 and pi over 2. Therefore, if we call this angle the alpha, if we say if we call arctangent of x is some alpha, so alpha is gonna be between minus pi over 2. So this is minus pi over 2 and pi over 2. And here we know that the sine of the angle, any angle here, alpha, that's between minus pi over 2 and pi over 2. So it's sometimes positive, sometimes negative. It's not constant in sign. Here, when it's between minus pi over 2 and 0, it's negative. And when it is between 0 and pi over 2, it's positive. Okay? So we're going to use this idea here when we try to simplify. The key to simplify this one is to link the sine and the arctangent, or the tangent. Okay? Here we know that 1 over sine squared of x is 1 can be written as sine squared of x plus cosine squared of x. Okay? We know that's 1 for any x, and dividing that by sine squared, we get 1 plus cosine squared of x over sine squared of x. So we know that sine over cosine is tangent, but this is 1 over tangent squared of x. Okay, so simplifying one more time, we get tangent squared of x plus 1 over tangent squared of x. Now we treat x as our arctangent here. Okay, so before doing so, we're gonna write this one as, so if we flip, we get sine squared of x is tangent squared of x over 1 plus tangent squared of x. Now, if we take the square root, okay, we're gonna have the sine in absolute value and tangent in absolute value over 1 plus tangent squared. Why? Because the sine is we are x is between minus pi over 2 and pi over 2. So this one can be positive or negative depending on where x is located. The same thing for tangent. But we know that the sine and the tangent of x, they have the same sign. Okay, so they have the same sign. So therefore we can write this one as sine of x is tangent of x over the square root of 1 plus tangent squared of x. Okay? And therefore, if we switch back, so sine of the arctangent of x, remember that our arctangent is between minus pi over 2 and pi over 2. So here we have tangent, the arctangent of x over the square root of 1 plus tangent squared of the arctangent of x. Okay? So to conclude, we need one key idea, is that we know that the tangent of the arctangent of x is always x. Okay? So this is always x. So therefore, we're going to use that here. So we're going to get, this one is x over 1 plus x squared. And that's what it means for the sine of arctangent of x. Okay, so this is the easiest and the final simplification that we can do here. So we have some more key ideas that we need to be aware of. Sine of x and tangent of x, they have the same sign. Graph that and you're gonna see that. Okay, they are either both positive or both negative, and the tangent of the arctangent is always x. Prove this one if you don't know it. It's very simple to do. Okay, and this means that we found the expression that we need here is that sine of arctangent of x is just x over the square root of 1 plus x squared. Okay, this ends our video, and if you see any errors or mistakes, please let me know. Thank you.